Who asked me to convert this to base 10? Nobody. But if I don't do this, how can I survive to base 8? So now let's bring this number here to base 8. Are you okay? You're okay. Now step 2. Convert 99 base 10 to base 8. And what is the base 8? That is a long division method, remember. Now how many times can 8 go into 99? Check. Mental checks, calculator checks. Yes. So 12 times, right? Now what is 8 times 12? 96. 8 12 is 96, right? So what will I add to 96 to arrive at 99? 97, 90, 99. That is what? Remember, 3. Now 8 will go here. 8, 1, 8. 8 to 16. That's too much. So 8, 1. So 8 will go here, just what? 1. I put them together in the usual way. 8, 1, 8. What will I add to 8 to get 12? 4. Can 8 go into 1? You can choose your zigzag approach. If you want to close up, then that's 0 when the number you see. That is if you see the number. You pick from bottom up. So the answer here, 3, 4, 4 base 5 will give me 1, 4, 3 or 1, 4, 3. You know the method we're going to use, right? So that is 1, 4, 3 base 8. You're welcome. So that is it. Okay, so you are welcome to equations involving number bases. Equations involving number bases. So what makes it an equation? The presence of this equate here, what you call equal to, right? Makes an equation. We have a left hand side of this equation and a right hand side. Now what will I do? The left is equal to the right. That is why it has been presented like this. But you can't see it physical, right? Unless we test it mathematically. So before I find x, this 25 is in base x, this 17 is in base 10. And when you have a number like 17 base 10, you know it is the same as 17. Let's prove it and see. If I have here 17 base 10, so I have 1 times 10 plus 7 times 10. This is 0, this is 1. I'm going to get 10 plus 7. I get 17. So when you have a number in base 10, why then do you want to convert it again? It's tautology, waste of time. So 17 base 10 same as what 17. But that is why if a number has no base, it is an automatic base what? 10. Now, before I do this work, if the right hand side is base 10, then let me convert the left hand side also to base 10, then I can make the judgment of comparison. Again, 25 in base x, change it to base 10. Then you can compare it to the right hand side when it's already in base 10. Because it's very difficult for you to change this one to base x. Always clear. Good. So before you do, make sure you change the left to base 10 to look like base 10, right? Before you solve. So let's start it. So here, (25) base x equals 17 base 10. So 2 by x. What am I doing here? I am changing to base what? 10. Good. Now you carry a power. You carry power 0, power 1. Then is 2x. Every number raised to the power 0 is what? Is 1. So I have 2x plus 5 equals what? 17. Good. 2x plus 5 equals 17. Now, 2x equals 17 minus 5. I'm grouping like terms, right? So you have 2x equals what? 12. Good. Now, you have to divide through by what? 2. X is 6. Good. If you put 6 here, and you expand, you get 17. That proves the equation. So that is it. So let's look at the next question. That's a sample what's the question, right? 2008 question 6. I have 32 base 5 to 101 base 2 plus 12 base x. It means that is not qualified, right? I have to change everything I say to base what? 10 before I can make the comparison, right? So I have 32 base 5, 101 base 2, plus 12 base x. Good, right? Okay. So I have 3 times 5 plus 2 times 5. 1 times 2 plus 0 times 2. What am I doing? I am converting to base 10. 1 times 2 plus 1 times x plus 2 times x. Right? Good. So I'll give them their respective powers. Now watch. This is 0, 1, 2, 3. What is going on? Am I right? Someone will say you are right because there is a left, there is a right. I'm not right. It's supposed to be 0, 1. You see, there are 3 terms here. So they don't have a continuous base powers, right? Good. So there is 0, 1. That is all. Start another one again. So here will be, there is 0, 1. Okay. Good. So you start here, 0, 1 here, and 2. And you start another one again, right? That's 0, 1. Please be careful when you get here, right? I don't do it continuous because see, there are 3 different times. That's what I see. Now, that is 15. Agreed? Every number raised to the power 0 is 1. So this is 2. 2 squared is 4. 4, 1, 4. 0. I don't even need to think. 0 by a number is 0. Right? Every number raised to the power 0 is 1. So that's just 1. 1, 1, 1. That is 1x. Every number raised to the power 0 is 1, not 2x. 2. Are you okay? Good. 17. 4 plus 1 plus 2. I'll get 7 plus 1x. Why didn't I add the 1x to the 7? But they're not compatible. How can I add them, right? Good. Now I carry this one over there. I continue from here. So that is 17 minus 7. Why? I am trying to group like terms. 17 minus 7 will give me 10 equals x. That is tantamount to 1x. That is the end. Are you okay? Good. Quadratic equation. Meaning we have to read the quadratic before getting our answer. Good. So it comes in here again. If you are struggling with the quadratic, you still have problem here. Good. So let's go. 1, 2, 3 base x equals 38 base 10. I need to convert the left to base 10, right? It is already base 10. Standard. That's okay. So 1 by x, 2 by x, 3 by x equals 38. I don't need to do further conversion here. It's the same. 0, 1, 2. X squared. Do you agree? 2x. Every number raised to the power 0 is 1. 3. 38. Wow. What is going on here? I need to do rearrangement, right? And these numbers are similar. So the 38 comes in. See, that is the meaning of the arrow. It is coming in case you can see. X squared plus 2x plus 3 minus 38. Why minus 38? It was positive here. It was positive here, right? So it comes in there and leaves 0 here. It's negative here, right? Good. You can see x squared plus 2x plus 3 minus 38. That is equal to 0. Why is it negative here? It was positive here. So when you cross this equal to sign, you become negative. And why is 0 here? Now, if 38 decides to leave his position and relocate, you leave 0 there. If you are seated here and you get up from this seat and I ask, how many students here? The number is 0. 0 is a number. That is why you see 0 there. But you see, I didn't force 0 in my work. Can we sit down? Now,